morning. Here we are going to start the Charpit's method to find the complete integral of first order partial differential equations. What is the working rule for this? First, we need to write the given equation in this format, f equal to 0, right? And then we need to find fx, fy, fz, fp, fq. What is fx? Fx means differentiating f with respect to x. Likewise the other ones. And then we have to put all these values in the Charpit auxiliary equations. This. It is very easy to remember these equations. First it is written dx divided by fp equals to, when writing dy, just divide this by fq. For dx divide by fp, for dy divide by fq. Then dz divided by p into fp plus q into fq. Then it is equal to dp divided by negative of fx plus p times fz. Then also equals to dq divided by negative of fy plus q times fz. Here it is written p times fz for dp. And here it is written q times fz for dq. And then we select two ratios from these equations and find the values of p and q. Select any of these two ratios from these and find the value of p and q in terms of x, y, z. And then we use dz equal to p dx plus q dy to find the complete integral. So let's move on to one example. Find the complete integral of z equal to pq using the Charpit's method. So first step is to write this equation in the format f of x, y, z, p, q to be equal to 0. How to write this? We suppose let f is equal to, take pq to the other side, z minus pq, right? So now we need to get the values of fx, fy, fz, then fp, fq. We need all these values to put all these values in the Charpit's auxiliary equations. Okay, what is fx? The derivative of f with respect to x. There is no x. There is no x in this. So this is 0. And also there is no y. This is also 0. Derivating f with respect to z is 1. Derivating f with respect to p is minus q. Derivating f with respect to q, it is minus p. Okay, now we write the Charpit's auxiliary equations. We have to put all these values. First I am going to write the Charpit's auxiliary equations. So this is dx divided by fp, dy divided by fq, dz divided by p into fp plus q into fq. It is very easy to remember. Then dp divided by negative of fx plus p times fz. Here I am having p, so multiply p with fz. Similarly, dq divided by negative of fy plus q times fz. Okay, dx divided by fp is minus q. dy divided by fq is minus p. Then dz divided by p times fp, that is minus pq, plus q times fq, that is again minus pq. So that is minus 2pq. Then dp divided by fx is 0. fz is 1. So this is minus p, and dq divided by fy is 0 and fz is again 1. So this is minus q. We can take away all the negative signs because all these ratios are equal. Now choose any two ratios to get the values of p and q. And let me choose dx divided by q and dq divided by q. I'm having the same denominators q over here, right? Similarly, we can also choose dy divided by p and dp divided by p. I'm having the same denominators p and p, right? Okay, let's choose the first one. We have chosen dx divided by q equals to dq divided by q. So cancelling this, we have dx equal to dq. When integrating both the sides, we get x equal to q plus the constant a. A is the constant. Similarly, choosing the another two, this is the first one. Second, we have chosen dy divided by p and dp divided by p. Cancelling the denominators, we have dy equal to dp. Integrating both the sides, y equal to p plus the constant b. B is the constant for this equation. So it is very easy to evaluate. Okay, from here I get the value of q to be x minus a. From here I am getting the value of p to be y minus b. So these are the two values I have got for p and q. And now the next step is to use the equation dz equal to p dx plus q dy. Because we need to get the solution z equal to what? Instead of putting the values of p and q in this, we can also put these values directly in the given equation. This is the given equation z equal to pq. So I can directly put the value of p and q over here to get the solution, right? Instead of solving this. So in this example, we are going to put directly the values of p and q in the given equation. Z to be equal to, what is the value for p? It is y minus b and it is x minus a. So it is y minus b into x minus a, where a and b are arbitrary constants, is the required complete integral of the given equation. We can also change this solution to z equal to y plus b dash x plus a dash, where you can use b dash to be equal to negative of b. If you want the signs to be positive in the bracket, that doesn't matter because these are the constants. You can use any value of a and b, negative or positive, it is the constant. Right, so this is also the correct one and this is also the correct one. Okay, thank you.